Hey guys, this is your classmate Ayush Saha back with another video. So this time I'm going to be focusing on like a lot of the topics in homework 6. So this video will show you how to do them, and after this video you should be like pretty well set strongly for the topics from this week. So yeah, let's get started. First one is a problem I made up of big theta. Show that for this thing, this is big theta of this. Um, so what you would do is, the way you'd prove that is you have to prove that this is a big O of this, and also that this is a big omega of this. So let's do that. So first step, big O. So what you do is you have to assert like a C value for C equals something. Let's say 20, because 20 should work. Remember that the C value is basically what the C value is that this thing times C would be greater than this after some point. So yeah, let's just choose 20 because that's a pretty high value. And then if you graph 20x to the 9, then you would end up with a graph that like you'd end up with a graph that like is like higher than it ever, like right after x equals 0. It would be the graph of this one would be higher than this. So basically you can say that for k greater than 0. And then next, proving big omega. So this whole thing is big omega of x to the 9 for, let's just assert a really tiny value, 0.01, and so this should be and k, so that should always be less than, so after k is greater than 0, then and sees this, and this should always be less than this, so that's this c and this k value works. So basically, because we proved that this thing is both big O of this and also big omega of this for these different C and K pairs, that basically proves that this thing is big theta of x to the 9. So therefore, there's our conclusion. Next thing we're going to do is induction problem. This is similar to for number 2 of homework 6. So then let's start with, so we're given this, and we have to figure out what is the inductive hypothesis. So that's pretty simple. Literally, the inductive hypothesis is just this statement. So all we would do is rewrite that. P of n to, and that's what the inductive hypothesis is. Now, the base case is when n is at the lowest value that n can be. So n should be, we start at n equals 1. So P of 1 base case, P of 1 equals P of 1, which is stating that 2 times 1 equals, and we plug in 1 to this side, 1 times 1 plus 1, and then we simplify that to 2 equals 2, and then that's true. So the base case holds. Now we're going to prove the inductive step. Well, what we do is we first believe that P of n is a true statement. So this first thing, believe. Step 2 is to prove P of n plus 1. So what we would do is we would write it out. So 2 of 1 plus 2 of 2 plus. So that's what P of n is, and now we're going to add the n plus 1 term. And so there we go. And we're stating that that should be equal to, now we change these terms in here to n plus 1 and then n plus 2. Basically, we change n to n plus 1. So it would become, basically for each occurrence of n, we just add 1. Now we would have to prove this. And if we prove it and it ends up at a conclusion of like something equals the same thing, if something equals itself, that means that we just prove it. So here, let me do that for you guys. So okay, so notice that what we would first do in proving this is we would first notice that this part, because we're assuming that P of n is true, we're going to assume that this part would be equal to n times n plus 1. So n plus 1. Now we add 2n plus 1 equals okay, so there we go. Now we have to prove this statement. And yeah. So we can simplify this to n plus 2 plus 1 equals n plus 1, n plus 2. As you can see, the left and the right side match. So we have just proven that P of n plus 1 is true. So because we have proven that P of n plus 1 is true, we have basically we prove the statement P of n using the inductive step. Okay, so the number 2 on homework 6 should be a very similar format to that. Okay, so number 3 of the homework, this will be a kind of tricky one, so I'm not going to solve it, but I'll give you guys a hint. So what you would do is you have to figure out what the value of this summation is at n equals 1, and at n equals 2, and at n equals 3, and at n equals 4. So at n equals 1, the value of the summation is just that. At n equals 2, the value of the summation is that plus that. And you keep on figuring it out for n equals 3, n equals 4, what the value is. And then you'll notice a pattern and of the numbers. So based on that pattern, you'll be able to kind of figure out at n equals some number x, what this thing is, what the value is in terms of x. And so basically you'll be able to make a formula based on the pattern you'll observe. Just write it out and it should be pretty doable. So the next thing I'll show you guys is this is like number 5 of homework 6 with the proof by induction for some sets and stuff. So let's see. So first, remember that this whole statement, right, that we have written here, this whole thing is P of n. So we first would start by proving the base case. So base case n equals 1. Then the base case is saying that. So if we write out the base case, we'll be doing equals a of 1. So I just wrote out the base case for both sides, and it holds true. So now we prove the base case, so now we can move on to the inductive step. So we would, remember we would assume that P of n is true, and then we would prove P of n plus 1. So let's write that out. So So there we go, and then we would prove that. So what we would do is we would first simplify this using the, what's it called? I think distributive law. So this would be equal to a of 1 intersection with a of 2 intersection dot 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 intersection. Or yeah, remember to put the not symbol on top. So there, I just simplify that by and then if you notice, we just, by simplifying this, we just arrived at this thing is equal to this thing. So we're like literally already done. That holds true. And this is a pretty easy and straightforward example. In some examples, like if it's like in some harder examples, you might have to show that you might have to do that step of believing that P of n is true in order to solve this thing. So in some more complicated examples, you'd have to be like, okay, so this part of the this thing is equal to some part of, or never mind. Basically, yeah, that's how you do it. What I just showed. But sometimes you'll have to do that step of believing that P of n is true, and then rewriting this as whatever is provided in order to solve it. So now let's get on to number 7. So give a recursive definition of that sequence if a of n equals that. So this one, I won't really directly solve it. It's pretty straightforward. I'll just give you the very general hint. All you have to do is, so n starts at 1, so you'd have to do assert what is a of 1. So a of 1 equals something. Now, if a of 1 is this value that you give it, then what would a of n be based on a of n minus 1? So I'll write in terms of. So that's literally all you do. Just figure out what a of 1 is and what a of n would be in terms of a of n minus 1. So yeah, that's my quick overview of the homework number 6. Hopefully that helps. I know that sometimes we get problems that like look hard but actually are pretty easy. So that's why I thought that this video would be a good idea. Thanks for watching, and hopefully you found it helpful.